Today we're going to discuss how to graph a quadratic in intercept form. A quadratic written in intercept form is written as y equals a times the quantity of x minus p times the quantity of x minus q. Remember, we have minus signs inside of our binomials. That should stay there to represent our variables. Let's look at our steps now. Just like the other forms, before we start our steps, we first need to identify some values. For intercept form, we're identifying values for a, p, and q. Step 1 is similar to before. It says, does the parabola open up or down? We know a parabola opens up when a is greater than 0 and opens down when a is less than 0. Let's move on to step 2. Step 2, we're going to identify the y-intercept. We're going to let x equal 0 and solve for y. Step 3, we're going to determine the vertex. Now there's an equation to find our axis of symmetry. Remember, our axis of symmetry is the x-coordinate of our vertex. The equation to find x is p plus q divided by 2. Once we solve for x, we're going to use x to solve for y. And that'll give us our vertex at point x, y. For step 4, we're going to determine the x-intercepts. Your x-intercepts will be found at p0 and q0. Remember to watch those for those negative signs. So if there's a plus in the binomials, p and q would be negative here. Let's look at an example together. So let's start with our example. Y equals the quantity of x minus 5 times the quantity of x minus 3. We're going to first identify a, p, and q. Remember, a is found in front of our binomials. There's nothing here, so we can assume that it's going to be a 1. Positive 1 at that. Here we have p, which is after x minus in our first binomial, so here we have a positive 5. And q would be a positive 3. So let's go ahead and start with step 1. Does my parabola open up or down? Well, based off the fact that a is equal to 1, we know it's greater than 0, so it opens up, and it has a minimum point. Number 2 says to find the y-intercept. So when x equals 0, what does y equal? Well, let's see. Y equals 0 minus 5 times 0 minus 3. Y equals a negative 5 times a negative 3, which gives us a positive 15. So when x is 0, y is at 15. Sorry about that. Step 3 says to find our vertex. And our vertex, remember, we have to start with that equation for x first. X equals p plus q divided by 2. So if I plug that in, p is equal to 5, which I figured out before. Q is equal to 3 divided by 2. 8 divided by 2 gives us the x value of 4. So to remember to find my y value, I'm now plugging 4 back into my original equation. So I get y equals 4 minus 5 times 4 minus 3. Here y equals a negative 1 times a positive 1, which gives us ultimately a negative 1. So my vertex is at 4, negative 1. And my last step is to find my x-intercepts, which I'm going to do right down here. Remember, they're at P0 and Q0. So my x-intercepts are right here at 5, 0 and 3, 0. Let's go ahead and graph that information on a graph. Let's review what we have. We're looking at a quadratic in intercept formed. We have y equals x minus 3 times x minus 5. We know that the graph is going to open up. Our y-intercept is at 0, 15. Go ahead and plot that point right there. We know that our vertex is at 4, negative 1. So if our vertex is at 4, negative 1, our axis of symmetry is at 4. So I'm going to go ahead and start with that and draw our axis of symmetry in. Here we have our axis of symmetry at x equals 4. Okay, let's plot our next point, which is our vertex at 4, negative 1, which would be right here at x equals 4 and y is negative 1. And then we have our y-intercepts at 0, 3 and 0, 5. So right now I have 1, 2, 3, 4 points. To find my one additional point, I'm going to reflect my y-intercept across the x-axis. So as you can see, I'm 1, 2, 3, 4 points away from the x-axis on the left-hand side. So I'm going to go 1, 2, 3, 4 points on the to the right of the axis of symmetry to get my last point, which puts me right here. At 8, 15. And so I can go ahead and connect all my points. And there we can see I have a very narrow parabola. But there we go. Let's try another one together. Okay, so here's our second example. We have y equals negative 3 times the quantity of x plus 5 times the quantity of x minus 2. Remember, we're going to identify A, P, and Q first. So here we have A is equal to negative 3, P is equal to negative 5, and Q is equal to a positive 2. Let me show you real quick why. Remember, our original equation is x minus P. So if we have x plus 5, it's like saying x minus a negative 5 in order to make that a positive in the middle. Okay, so let's go on to step 1. We're looking at A. If A is greater than 0, it opens up, but here we know that A is less than 0, so it opens down, and we have a maximum. Step 2 tells us we're going to look at the y-intercept, which means we're going to plug in x equals 0 to find our y-intercept. Here we have y equals negative 3 times 0 plus 5 times 0 minus 2. And we gave you a moment to go ahead and figure that out on your own. Maybe put it into a calculator. It's negative 3 times 5 times negative 2. I got positive 30. Hopefully you guys got the same answer. And let's move on to step 3. Remember step 3, we're going to find our vertex at the point xy. To find x, we have a new formula, which we have x equals p plus q divided by 2. Go ahead and plug those numbers in that we have. We have negative 5 plus 2 divided by 2. Negative 5 plus 2 gives us a negative 3 divided by 2. Thus our axis of symmetry is equal to negative 3 halves. And now to find our y-coordinate, we'll have to plug that value back into our original equation. And I'm going to show you how to do this, exactly how you would put it into the calculator. put -3 in parentheses, times, you're going to have to put 2 sets of parentheses here. You have -3/2 in parentheses, plus 5, close out your parenthesis for the whole binomial. Once again, same thing, -3/2 is in its own parentheses, minus 2, and close out your parentheses. Put that in the calculator, let me know what you get for a y value. So I got x equals 36.75, which can also be written as y equals 36 3/4. Okay, we'll look at our x-intercepts next, and then we'll graph the whole thing together. Okay, so we had our example. We know that it opens down. Our y-intercept is at 0, 30. Our axis of symmetry is at x equals -3/2. Our vertex is at -3/2 and 36 3/4. Now our x-intercepts, remember, are at P and Q. Remember, our x-intercepts are at P and Q. So our first intercept was P, which is -5, 0. And our other x-intercept would be at +2, 0. So let's go ahead and plot these points on the graph. Let's start with my y-intercept, which was at 0, 30. So I'm going to go ahead and put a point right here at 0, 30. Then I'm going to look at my axis of symmetry, which was at -3/2, which is kind of right up against this 2 line, not quite on it. Do your best to guesstimate when dealing with fractions or decimals and graphing. Obviously, it's not going to be 100% perfect, but you want to make sure it's somewhat accurate. Let's look at our next point, which is our vertex, which we had at -3/2 and 36 3/4. So here we find 36 on this line, so I'll put it a little bit above. And there we have our vertex. Next, my x-intercepts, which I had at 2, 0. It's going to be on my x-axis, and -5, 0, which would be halfway, like right about here. Once again, this is going to be a very narrow parabola. I have 4 points. To find my 5th point, I'm going to mirror my y-intercept across the axis of symmetry. It doesn't go too far. Should go right here on this point. And then if I connect my points together, once again, like I said, it's going to be a very narrow parabola because the way we counted our points out. But there we are with our next parabola. Try some examples on your own next. Here are 2 examples. Try them on your own, and we'll remember the 4 steps to solve each problem, and we'll complete these together in class.